Today we're going to have a look at the Fibonacci sequence, and it's a sequence of numbers, so it's a number pattern. And can anyone tell me, are the numbers increasing or decreasing? Good, yes, they're increasing. So which operation is being performed? Yep, addition. And how much are the numbers increasing by? Let's have a look. 1, 1, 2, 3, mystery number, 8, 13. Yeah, we can see it's not increasing at all from here to here. It's increasing by 1 again, but then something strange starts to happen. That's because this is actually a famous number pattern, and what happens is after the first number, the first and following number after it, so the second and third, they're added together to get the next number, and that is the rule in the Fibonacci sequence. So let's have a look. If we go 1 plus 2 equals 3, 2 plus 3 equals 5, gives us our next number in the sequence. 3 plus 5 equals 8. 5 plus 8 equals 13. 8 plus 13 equals 21. 21 plus 13 equals, that's right, 34. And then we would have 21 plus 34 would be 55. And it starts off with whole numbers and goes on and on and on until eventually there are so many numbers that you come to the golden ratio, also known as phi, which is 1.618. And phi, or the golden ratio, is important in nature because it creates a spiral design. So let's have a look at how that's possible. To make it a bit easier for you to see, what I've done is on this grid paper, I've applied the Fibonacci sequence, a number pattern. It starts off with a 1 by 1 square, and then the next number is also a 1 by 1 square. So remember, it doesn't apply in this step, but then we start adding them together. 1 and 1 is 2, so I've got a 2 by 2 square. 1 and 2 is 3, 2 and 3 is 5, see how the squares are growing. 3 and 5 is 8, 5 and 8 is 13, and 8 plus 13 is 21. So you can see here, I've put them in different colours so that you can really clearly see how it's growing. Now what happens is, with the Fibonacci sequence you have a square, but when the next number is added to it, it creates a rectangle, and because of the length and width of the rectangle, they're in what's known as, it creates the golden ratio for the spiral. And the spiral starts and in the middle here, and it always goes from one end of the square to the other in an arc. So as we can see here, it starts to spiral out and it starts to grow larger and larger. So if I show you the next number in the sequence of the one we've just done, you can see it goes, and after 21, 34, and it gets bigger and bigger and bigger. So let's have a look at a couple of examples in nature, because the spiral design is seen a lot in nature. Things like pine cones, pineapples, sunflowers, fern fronds, shells, and even snail shells. This is a nautilus shell, and you can see the Fibonacci spiral growing bigger as it goes out. Here are some more things that you might not expect would have the Fibonacci sequence. So our ear follows the same thing, and you can see here the grid we were just looking at has been applied to this so that we can understand it a bit better. And the nautilus shell here going round, flowers, even spirals in the galaxy and spiral staircases in buildings also use the same construction principle within the Fibonacci sequence. And I'm just going to show you a real life shell. So you can see this creature obviously started off very small, and as it started growing and making its shell, the Fibonacci sequence is applied until a big creature lived in this shell. It's a bit harder on this pine cone to see because of the light, but you can also see the spirals there that go around, and it's really good to have a look at things like pineapples, as I said, because you'll get a really good idea of how the Fibonacci sequence works. Also happens in plants. If you start counting the number of branches or the number of leaves on a stem, you'll also notice that pattern. It's absolutely everywhere. So get out there, have a look, explore, and see if you can find some examples of the Fibonacci sequence in real life.